series of the Doctoral Consortium series on intelligence. The Doctoral Consortium is a platform we set up in Digital Futures for sharing tutorials, sharing information with doctoral students all over the world. The idea being that on the whole, most doctoral students work together with their professor in isolation. Why not have a global platform? The theme of this particular series is intelligence, and I'm delighted to be able to welcome Carlo Ratti as our guest this week. Carlo is kind of doesn't need an introduction, but let me give him an introduction anyway. Originally from Torino, he's studied all over the world in Italy and in France, and also at the University of Cambridge, where I myself studied. He is the founder of Carlo Ratti Associati, if I pronounce that correctly. He's also a professor at MIT, where he's in charge of the Senseable City Lab. And of course, everybody will know him this year as being the curator of the astonishing Biennale in Venice, the Architecture Biennale in Venice, which he called Intelligens. And no doubt he will explain precisely what he means by that title, Intelligens, Natural, Artificial, Collective. But let me simply say that this is, I think, one of the most astonishing biennales of all time, and it comes at a particular moment in the history of architecture and the history of AI in particular. We live in the age of AI, but it's a more comprehensive exhibition than just focusing on AI itself. But as you all know, it was an astonishing indulgence of extraordinary exhibits across these three domains. Let me just simply say that this is part of a series. Next weekend, we have Stephen Wolfram at the unusual time of 1 p.m. EST. That's 3 hours later than we normally do. After that, we have Catherine Hales, followed by Philippe Morel, Patrick Schumacher, and Refik Anadol, who will be in person in Design Miami on the 4th of December. And then next semester, we have Blaise Aguirre-Arcas, who is the author of this astonishing book, What is Intelligence?, which comes out on the 23rd of February. And of course, there's Catherine Hales' book as well, Bacteria to AI. So the whole series, I think, is dealing with something that is enormously topical, the theme of intelligence, both at the Biennale and also in terms of these books coming out right now. I will stop sharing my screen and just like to say, welcome to Carlo. It's fabulous to have you here. Carlo is actually in Brazil. Carlo is all over the place. I used to say of Patrick Schumacher, open your fridge door and there's going to be Carlo, but it's going to be Patrick. But the same is true of Carlo. He's literally, he must be cloned. Carlo, fabulous to have you here. Thank you so much for joining us.
Neil and Dalton, thank you very much, and thank you for this beautiful introduction. I'll share my screen. Just a second. Here we are. All right. So I thought I'll just share a few slides and then we can have a conversation. Yes. So again, great. Thank you for inviting me. Great to be with you, and also looks like an amazing lineup this semester. So what I wanted to do today is share with you a little bit of the work we do in architecture. That's with CRA in Turin, New York, and in London, and a bit of the work we're doing with Senseable City in the framework of the Biennale. I'll start with the Biennale in a moment. Senseable City started in Boston as a research lab in Boston, and now we also have a few smaller labs in different countries. The reason being we want to try to work with cities to learn from their problems and making sure that the research we do can also then be turned into policy in different cities, into projects and so on. But as I was saying, as Neil was saying, I want to start for a moment with the Biennale. I will try not to give you a full spoiler. The Biennale is still open until the end of November if you are around Venice or Southern Europe before then. So the theme this year is intelligence. We like to. The reason we're spelling it like this, intelligence, that's Latin root behind both Italian and English. And so for us was, first of all, a way to use only one single title, not the two titles usually the Biennale uses, the Italian, the English title. But also we like this idea of gens, or better gens, which is about plurality, about people, about a multiplicity of intelligence. And to be honest, at the beginning, when we're starting to think about the Biennale, one idea was to call it NI. Today, when you say intelligence, everybody thinks about AI and about even smaller, about LLMs and so on. And I think there's so much more intelligence in the natural world that architecture has been leveraging for thousands of years, and that we need to continue leverage. So the initial idea was to focus more on natural, but then in the end, we decided to have natural artificial collective to try to see at a time of adaptation how we can leverage all different types of intelligence. And so that's the title, as I was saying. The Biennale is a little bit like there's a lab that's a visualization done in an interdisciplinary team. Many teams are interdisciplinary. I'll get back to that in a moment. In this case, a team that has, for instance, Laszlo Barabasi is a great physicist, Paolo Ciccarelli, who does data visualization and data analytics at Northeastern University. In this team also, you've got Michele Bonino from Politecnico di Torino and others, where they actually looked at all the different ingredients coming together in the Biennale. And this year, it's quite a large Biennale. We like this idea of a lab. And in a lab, you really want to put together many ideas in a way that they can spark new conversation and new links. So we got over 750 participants. I got a slide on each of them. I'm joking here. I will not show you slides for each of them. I will just give you a little bit of key data. 750 participants, over 750, around 280 projects, all in the Arsenale. First of all, because the Giardini site at the Biennale this year is under renovation. So we had the Arsenale and the parts around the Arsenale. But we like, again, this idea to condense them in order to create new connections among them. Over 500 participants in interdisciplinary teams. So in the teams, you will find in Venice, architects, planners, designers working with scientists, with people coming from agriculture, from food, from many other disciplines. And again, different generations. You'll find Nobel Prize winners and Pritzker Prize winners, people at the end of their career, together with people just out of university, or even at the end of their university studies. I was also proud that over 250 are in women-led teams in a discipline, our discipline, that sometimes is rather biased from this point of view. And also almost 400 in transnational teams. The idea that when we're looking at solutions for adaptation, we need to go beyond the idea of, projects by one country, one nation, another nation. We need to work together. This is an image of the Arsenale. Again, as this kind of lab, you see the design of the exhibition done with SAB in Berlin. I think created almost kind of fractal organism inside the Arsenale. You see here, this was the initial idea that inspired the development. I'll show you a little video without spoiling too much of going through the different sections of the exhibition this year. At the beginning, the two key parameters for architecture: climate and population. The first project with climate, again, bringing together climate research from ETH in Zurich, together with Transolar as great climate engineers based in Germany. And also Michelangelo Pistoletti is an artist. And then the second one you see in a moment about population. Population has been growing exponentially on the planet, but now we know that it's about to go down. And how it will go down, if it will collapse or not, as you know, fertility rates are under replacement rates in most of the planet, in most of the world, in most continents, apart from small pockets in Asia, in parts of Africa, fertility is under replacement everywhere. And so that project as well has physicists, biologists, architects, and designers all working together to try to look at the key variable for the future of our discipline. So climate and population. Then from there, natural intelligence artificial intelligence, collective intelligence. I'll show you the little video. As I was saying, this is the beginning about climate, population, looking at climate and population in the next 50 to 100 years. And then we start with nature and this kind of first part is kind of raw nature, how we can use nature with its complexity in a better way, also using new technology. Nature is more and more tamed. In a moment, you see a lot of the experiments on materials. And then artificial with robotics. Not only AI as we think about it, but networks, sensors, robotics. For the first time, a large number of humanoids. And that's kind of a lab inside the lab. Humanoids being programmed by ETH, MIT, Tonji University, and Politecnico di Torino. You'll see them in a moment. And from there also the collective. That was the ETH project, and also a collective about people coming together even into a big conversation place in the middle of the Arsenale that you see, and also other pieces outside the Arsenale, outside the Corderie, still in the Arsenale. Really looking at Venice as a living lab, so using different design opportunities like a new evaporator station or cleaning the water in Venice to design new elements. And using them as new opportunities for design. This is the beautiful bookshop we had to redesign because of the refurbishment, and that was done by Tindra Scofidio and Diane from Furstenberg. So they're just a little glimpse at Venice without spoiling too much. But I thought what I will do today is focus mostly on the work we're doing at MIT across this different type of combining different type of approaches in studying the city. And for each of the chapters, I will share with you at the end a little bit about how we are turning it also into design projects in different cities. So starting with mobility. This is a very old Biennale. It's a Biennale in 2006. So now almost 20 years ago at the time. The role I had this year was by Ricky Boudet. Ricky was the director of the Biennale in 2006. And we had a pavilion inside the International Pavilion, where for the first time ever, there we looked at data coming from networks, in this case from the cell phone network, to describe the city in real time. That had never been done using cell phone data. Today it happens all the time. If you just take your phone and open Google Maps, you get this kind of real-time data from the city. But it was the first time ever on the planet that we managed to use the data from a big telco operator in order to describe the city. So the city was Rome. The exhibition was in Venice in 2006 at the Biennale. We set up this kind of proto-cloud at MIT. You see here, we collect all the data from Rome in real time, starting from the cell phone data, and then you would analyze it at MIT and send it back in near real time to Venice. Now, that year or so, while we were monitoring Rome, there was also the soccer World Cup, and look at what happened that year. Here you see Rome, the Colosseum, the river. That's the day of the soccer World Cup in 2006. Before the match, people move in the city, go here and there. That's the early afternoon, as you see up on the timeline. In a moment, the match begins. Silence. Nobody talks anymore. France scores, Italy scores, halftime in a moment, people make a call and go to the loo. Second half in the normal time, first overtime, second overtime, and a famous headbutt by Zidane, and finally Italy wins. And here you see people, all going to celebrate and spreading in different parts of the city. So this was kind of the first time we ventured in this type of new data to describe the city. And since then, we've actually been using the data to really look at cities as complex systems. There's a paper in Nature Cities a couple of years ago where we looked at how we can use this kind of new data from networks to better understand, to delineate urban areas. Or we've been looking at other things. Some of you might know this beautiful book by George Zip. George Zip was a great mathematician and statistician in Cambridge, Massachusetts, at Harvard in the middle of the 20th century. And one of the things he discovered in this book is this gravity law between cities. If you got two cities, think about whatever, like Milan and Venice, and then the flows between the two cities. can be modeled using something which is similar to the gravity law, the Newtonian law. In this case, it's population 1, population 2, divided by distance power alpha, where alpha is an exponent between 1 and 2. At the time, this is something he reviews in the book, and that has been used a lot since then. But what we did with this new type of data about mobility, cell-phone data about mobility, in this paper, we discovered if you look not only at distance, but at the frequency domain, and you see it here, everything beautifully collapses on that line. So the very important variant that's an extension of Zipf law is that it's not only divided by distance power alpha, but the key invariant is distance times frequency. And the reason we can do this today, again, we can look at this, which is then very useful for cities if you need to plan new infrastructure and so on to better understand cities and flows. The reason we can now look at that through the frequency domain is that for the first time we have data such as the one I shared before. I want to give you another example of how we can use this data to understand cities. And that's something that bothered me since when I was a student at Cambridge, UK. And at one point I was living here this is actually Darwin College, and that's the house of Charles Darwin. And something puzzled me. And what puzzled me is that I was staying there. I was going to do research in a place called the Martin Center. And I was going from the college to the department following one route, by foot or by bike, and from the department to the college following normally a different route. And it was puzzling me because if you think about shortest path, shortest path is symmetrical. A to B equal B to A. So somehow it looked like my brain wasn't following shortest path, but was, you could say, consistently inconsistent. Inconsistent because it wasn't following the rational path between A and B, the shortest path, but it was consistently following a deviation from that. And so I was interested in that. I was saying, is this, how do we navigate space? That's an important question to better understand how our brain navigates space. And in this paper, a couple of years ago, 3 years ago, actually now 4, a bit less, 3.5, we looked at data, similar data about mobility in city, focus on 2 main cities in San Francisco and Boston. And actually what we discovered is that we don't follow shortest path. Human brain doesn't follow shortest path, follows something that's been observed with animal. This is a piece of research we've been doing with Josh Tenenbaum, who is in brain and cognitive science. He's been doing a lot of experiments on how the animal brain optimizes different things, including navigation. And so it is about vector-based terrestrial navigation. The point is that what we are doing is that we are following a vector and minimizing angular deviation from our destination. And here you see actually the results. And then when you look at this, in the city is not too different, but it is different, and also it is non-symmetrical. So under some condition, A to B is different than B to A when you're looking at vector-based navigation. And it is interesting because, first of all, we are more and more coupling organic intelligence, our intelligence, with the intelligence in our smartphones and so on, with artificial intelligence. So it's important to understand both of them. Our phones actually follow shortest path, but it looks at our brain was encoded for shortest path, was coded for something different. And the other interesting thing is that if you think about vector-based navigation, it's not too different. But in terms of computing power, is much easier. So you might see a trade-off happening, like probably tens of thousands of years ago, when our ancestors were whatever in the savannah and trying to go A to B. And probably you want to minimize computing power in your brain at the same time. So to have a good enough solution, an approximate solution, not perfect shortest path, in a way that will leave you enough computational power to look at other things, at other risks and perils you might have on the route. We've been looking at this type of data, mobility data, also with GPS data. There's actually taxi GPS data in New York, all public data sets. This is JFK Airport. You see every dot is a pickup or a drop-off according to the color. You see all of Manhattan here. JFK was down there in the lower part. By analyzing this, we also started doing different, asking different type of questions. By the way, a lot of these are design questions. They're not about how the city is, but how the city could be programmed in a different way. So the very definition of design about looking at how things could be different. And what we did in this way, you see in a moment in the video, is actually looking at how we could rethink dispatching in New York. In this case, nothing would change for customers, but we ask ourselves mathematically, what is the minimum fleet we need in order to keep Manhattan on the move? And you see here, this is real data from Manhattan. 50% of the time taxis are empty. They're just moving around looking for customers. And then what you see here is just by changing the intelligence of the city, the dispatching of the city, we could take everybody to the destination exactly when they need to be there with a much smaller number. Today, 8,400, tomorrow, 5,800 in this part of Manhattan. And these are all the papers you're interested in. You'll find them on our website. Or when you got all this data, you can look at other things. So in terms of mobility, traffic lights arrive on our roads when cars arrive on our roads. But now, if you got an intelligent system with location and real-time information, then you don't need to stop anymore. You can keep on going, just avoiding collisions like this. Don't try it yet. But I think this is a nice mathematical problem. You can look at this with Q in theory. And again, if you're interested in this paper, we try to expand on that and looking at how we think intelligent mobility in the way we negotiate access to intersections. And of course, then a lot of this can be turned into different type of design. There's a piece of design our office did with Waymo and Google. Waymo is one of the companies under Alphabet. Google's sister company doing self-driving cars. And then here, we thought about a road where the morning could be like this, when you got a lot of traffic, but in midday, it can be reconfigured for something else. Again, that real-time data can help you to reconfigure the city. This is the competition we won in Paris about rethinking the ring road in Paris called Périphérique in 2050. And the idea was really, again, how we can use space in a better way, dynamically allocate space dynamically. We can produce energy and help, to reconnect the city about it. So let's get a little glimpse of some of the things we can do with mobility when we got data and the intelligence. Again, there's, by the way, a small thing which is kind of obvious, but basically, you can have the most powerful AI, but unless you got data to train it, that's worth nothing. It's like an empty brain. So somehow data is feed the necessary food for AI. The same approach can be applied to studying society in more detail. We've been looking at this over the past 10 years, kind of pioneering a line of research about looking at integration and segregation in cities using data. We used to talk about ghettos in cities. Think about the ghetto, by the way, is a neighborhood in Venice called the ghetto, which is where the word comes from. But cities still today are quite segregated, but sometimes in an invisible way. With Richard Sennett, we call them liminal ghettos. And again, with data, we can look at them, defining this kind of statistical parameters. What is the probability you meet somebody different from you as you're moving through the city? So this was one of the initial articles we did. There's a more recent one from a few months ago where we actually looked at how mobility data can help us to look at the inequalities in a much better way. Something we couldn't see before, we can now with high resolution data. Also, we've been looking at real data around the world in order to look at this issue of segregation and integration in 15-minute cities. It's been a big debate recently in planning with this idea of neighborhood-based cities or 15-minute cities and what the impact could be also in terms of integration and segregation. But let me tell you also about still looking about communities, about an experiment that we did at MIT. And the experiment at MIT happened randomly during COVID. It was the experiment that usually you can never do in the social sciences, where you take one variable, you remove it, and you put it back. The problem with the social sciences, so when you're studying, like, social systems, cities, and so on, is that usually you can find a lot of correlation, but it's very difficult to intervene, like you might do in physics, where you take one parameter, you remove it, and put it back. Well, in this case, as you all know, COVID did that for us. So COVID discontinued physical space and then put it back 2 years later. And so the question is, what happened to a community when you don't meet in person anymore? And just before COVID, after a long approval process, we had started to collect anonymized data to define the MIT community. You see here, there's a network, anonymized network. The nodes are the people. You don't know who they are. The links are, if there are email exchanges, again, you don't know anything about the email, but there is a link between two people. And then you can create and do network science applied to the MIT community. So this data we're connecting and collecting, and we are collecting. We started at the end of 2019. Then on the 23rd of March, 2020, MIT went into lockdown. And so the question is, what happens to a social community, to a social network from the point of view of your telecommunication network, your exchange network, in this case, the MIT email network. What happens to that when there's no physical space? And something must have happened. Look at this. It's only like plotting just visually the network before lockdown. It looks like this. These MIT, the different schools and departments and so on. And then during lockdown, it looks very different. But what happened? What changed? And then we started looking at all possible network science parameters, and everything was the same. No difference before and after. So we couldn't figure out, it looks different, but most of the key parameters didn't change. Until when we started looking at this. This is only a definition. So if you think about your friends or your connections, you can put them into two buckets. One, you call them weak ties, one, you call them strong ties. So strong ties are in blue, and they're friends, your friends, who are also friends of another of your friends. So person A, person B, and A and B are also connected with each other. So basically, when you're plotting it, you get a triangle, as you see here in blue. But also you got weak ties. Weak ties are your connections who are not friends of your friends, but they usually become a bridge to another community. And then it's only a definition, so they're your friends, your connections, who are not connected to any of your other friends. Well, and many of you might know this paper, a very important paper in sociology from 50 years ago, The Strength of Weak Ties. Mark Gronovector, who's a professor at Stanford. Now, it was John Hopkins at the time. And the fact that strong ties are usually don't give us new information. We are in these triangles, we keep repeating the same thing. Weak ties are very strong because they give us usually access to new information. They are these connections to a new community, and they bring us more diversity, richness, being collected to creativity and many other important things. And so basically, now you've got the end of the story. So what happens when we remove physical space from a community is that the number of weak ties goes down. At MIT campus, it goes down by 80% during the lockdown period. The lockdown is 23rd of March, 2020, as I mentioned before. Even if people, over the previous couple of weeks, people stopped going to campus because it's already in the air. No, it's not full lockdown, but everybody is not encouraged to go to campus. And then you see they go down from 250 to 50, so 80% in that period. And then you see here, if you look at the overall, the visualization of the overall network, once again, it looks almost like a shrinking brain because, yes, we still have all the strong ties, but the weak ties disappear very quickly. And that's a paper, if you're interested in it. Again, we collaborate, different collaborators, including Robin Dunbar at Oxford, who some of you might know because of the Dunbar number about, the number of friends each of us has. But again, through data, we can better understand this kind of human dynamics, and we can do it also today with other things. Again, it's difficult to present without feedback, I'd like to ask the audience who's maybe you can do it. You can do it using some of the Zoom reactions. Obviously, who knows this? But this is so I don't know how familiar everybody is with this, but these are very well-known movies from the 70s and 80s, taken by William White in New York. And William White at the time pioneered taking footage in public space to really better understand how we interact in public space, and also how weak ties are generated in public space by meeting other people. And so he took a lot of footage at the time, and in his book, he talks about it. He was super influential at the time, but the difficult thing was how to analyze all the footage. He says in the book, in one of his books, he says, taking footage is easy, it's even fun, but actually then processing it is a very hard task. Now, as you all know, we can train an AI system to analyze footage. And so what we did here was go back in the same places that William White was filming 50 years ago, and also took more recent footage from the same places and looked at the difference between them. And so we started exploring the social life of urban spaces through AI. That's the paper now out in PNAS since a few weeks ago. Again, training an AI system to analyze public spaces. The beginning of a bigger exploration we want to do. In this case, we looked at a longitudinal thing over the past 50 years. And what you see, by the way, is very concerning. Interesting and concerning, the fact that we are using less public space to meet and socialize. It has become a more transactional space. We usually go there and maybe meet people we've met online, but that there's some of the dynamics that you can clearly see in the footage from the 70s and 80s don't seem to be there anymore. Or we are also looking at AI again in order to look at different dimensions of the city. For instance, looking at in this case social parameters in the city by looking. And in our office, we're trying to turn that also into design. That's a recent museum we designed in Milan, where in this case there were many different levels, and we tried to connect them with call it like a vertical plaza, but with the idea that this would become a place for people to meet and again to develop new connections and ties, to try to use architecture as a way to counter what happens only in digital space, which is we retreat and polarize just with strong ties. So trying to, again, if you think about this from a physics point of view, trying to create in this place, again, it was motivated because in this museum, you got two historical palaces in Milan, and then with different levels and heights. And so, but turning that into a place for people to meet. This is the new Milan Innovation District as well, where this kind of green corridor and common ground on the ground floor tries to do something similar, again, to create a space for interaction. Or this is a building in Singapore we just finished a couple of years ago. We did it together with one of the tallest buildings there, where actually the whole building opens up to let nature in and create a big plaza overlooking Singapore, again, as a place for people to meet other people and meet with nature there. And I'll go a bit fast, but also we've been doing something similar on Brasilia with the first major extension of the Brazilian master plan here in Brazil. Now, a couple of additional things quickly about autonomy and environment. About autonomy, we're getting more and more intelligence spread into objects, into our homes, and so on, and that is creating almost like a new ecology of organic intelligence blending with electromechanical intelligence, the intelligence of machines. Roombas in our home, robots on the factory plant, and here in this case, in Amsterdam, we started working with the city to think about autonomous boats. Boats, little boats, we call them rowboats, that you could use for moving things around, for moving people around, for a fencing and delivery system. But also think about like a floating architecture with these kind of little pixels that could connect to create a temporary bridge or a floating stage. Think about archigram on water. But then with intelligence, you can create a responsive, dynamic infrastructure for the city, which, by the way, is not in use what Venice has been doing for a long time, with gondolas creating a temporary bridge during the well-known Festa del Redentore. And I want to show you briefly how we did it. This has been a research project with MIT, TU Delft, and Wageningen University in the Netherlands. Today, you can very easily do a little model, something that 10 years ago would take you lots of time. Today, you can 3D print very quickly. That's the small models, 1 to 4 size, testing them in the canals. Oh, sorry. Testing them in the canals. You see they're symmetrical. They can also move laterally. And then again, you have an intelligent system, but unless you feed it with a lot of data, that is quite useless. So what you see here is the data we collected from the canals, but also data that's, every machine looks at the world through a LiDAR. Every second here, you get 300,000 data points in Amsterdam. And that's kind of the training for the machine. You see it in a moment. That's how any robot, any self-driving car today sees the world. It's the same thing we do with our eyes. Our brain is much smarter. Just with 2 eyes, it can get this 3D model around ourselves. But this is how we can approximate it for robotics. And then, if there's a little, you teach a system how to move. That's the MIT swimming pool. That's what MIT uses swimming pools for. You see here the robot and the little thing, and then the LiDAR at the top, avoiding different type of obstacles, also very complex ones, as you see here. So, the input is what you see here. It gets all the data, and then based on that, it makes decisions about where to go. And I'll show you now where we stand. That's at the end of the research project. And also with this, which here is the paper if you're interested. This is the video of how we finished the research project, and then how this was spun off into a company.
This is Lucy. Lucy is a rowboat, a fully autonomous, zero-emission boat that operates on urban waterways, and she can change the way cities work. As congestion and emissions continue to rise, while cities continue to grow, the existing infrastructure of many cities struggles to keep up. Rowboats offer a solution by moving road traffic to the water. By bringing passengers from A to B, or as an on-demand boat, taking you anywhere you want. And they can also help the city as a multi-purpose workboat. Take Crystal. She is equipped to collect household waste to free the streets from heavy garbage trucks. Rowboats are fully autonomous, so they navigate without a skipper and can operate 24/7. In order to sail by themselves, rowboats need to perceive their environment and recognize objects such as bridge pillars, floating objects, and of course, other vessels. The primary source of information comes from a LiDAR sensor, but rowboats are also equipped with cameras, GPS, and a digital compass. Rowboat's onboard computer combines and processes all of the data and runs the rowboat software so it can successfully complete its mission plan. After 5 years of development, testing, and experimentation, we have now successfully enabled autonomy on the full-scale prototypes. Rowboat is ready for the next step. Join us and let's unlock the potential of urban waterways together.
All right. Oops. All right. Just to finish, a few small things about the environment. Also, LiDAR, you saw it before, like you see here, this kind of 2 years or 2 LiDAR on self-driving cars by Audi from a few years ago. Also it can be used in order to sense the environment. The car itself can become a sensing platform for the environment. It can also become a way to, for instance, look at infrastructure. And you might remember this is an image from a few years ago of a bridge that collapsed in Southern Europe. This is for everybody who's done civil engineering is a very well-known footage of the Tacoma Bridge. This footage help understand what happens when suspension bridges vibrate, and actually was instrumental in rethinking a few decades ago how they are designed. But also, if you look at this, it's a bridge next to MIT. It's a bridge I used to cross twice a day. Longfellow Bridge to the left, MIT campus. To the right is Boston downtown, and the bridge has to be basically rebuilt at a huge cost, monetary cost, but also a cost to the city because the city was disconnected for a few years. And the reason is that it wasn't monitored, and then they realized when it was too late that the bridge had very serious issues, structural issues. And the reason is that today, if you want to monitor a bridge, you need to either put sensors, as you see to the left, you need to send people, as you see to the right, but the cost to monitor one bridge today in the United States is around $500,000 per year per bridge. So we'll never be able to monitor all the bridges in a country. Too expensive. And at the same time, what you collect with when you're monitoring a bridge is usually vibrations. You monitor the vibrations as the way the bridge vibrates. And today, there's many ways to record vibrations. Our cars do it. And then you can use there, you see a professional accelerometer and gyroscope. And then you see 3 phones, all of them have inside accelerometers and gyroscopes. So we started saying, what if we were to take a bridge and actually, can we monitor it just by using all the data from our cars and smartphones? And we decided to start with the Golden Gate because we got beautiful brown truth. We know everything about the bridge. So basically by collecting new data, we can easily compare it with all the other data that's being collected. And we started going back and forth across the Golden Gate Bridge to collect data with the car and those sensors you saw, including the phones. We went back and forth 100 times, and then the San Francisco police got quite a bit suspicious. We were pulled over, but we managed to collect all the data we needed. You see it here, and then it turns out you can actually look at exactly how the bridge vibrate from the data you can collect with app or with the car. And this is a paper, if you're interested, crowdsourcing bridge dynamic monitoring with smartphone vehicle trips. Here we then teamed up with Uber to get data from their apps. But you can imagine it then just by using data that we collectively collect and might want to share as citizens, or through many of the existing apps, you could monitor bridges in the entire country with a very little cost. We've also been putting sensors onto garbage trucks. You need 3 garbage trucks in order to sense a city like a Cambridge, Massachusetts. And by the way, also here there's a beautiful mathematics of very few trucks or very few vehicles allow you to scan a big chunk of the city. You see here in this paper that I showed before, that basically if you look at New York City, and on the x-axis the number of vehicles, on the y-axis the percentage of 3 segments out of the total 3 segments in the city that you scan at least once a day. You see, with just a very small number, like a few dozens of vehicles in New York, you scan at least every street. You scan 50%, you see 0.5, 50% of the streets at least once a day. And the same curve is quite beautiful. It's like a saturation curve. You find it in physics and in biology and in chemistry that basically describes this in cities globally. Something we've been doing recently is also looking at, with colleagues at Stanford, looking at fiber optic in cities, and using that, how it can tell us something about vibration. And it turns out we can do a lot of urban sensing just by using existing fiber optic and repurposing it as what is called DAC, distributed acoustic sensor, DAS sensor, distributed acoustic sensing. That basically, if you want, is like what you do in geophysics, but here by using existing fiber optic for sensing. We've been looking also at wastewater, and also a lot at waste in general. So if you look at the computer I'm using today, that's the last project I'm showing. A few years ago, we got interested in the fact that today you know everything about it. You know every chip, where it was produced, how it moved on the planet, how it became this machine. And then when you stop using it, You sell it, at some point somebody will throw it away, and then you know very little. So today we know everything about how things are made, very little about what happens at the end of life. So we started thinking, what if we were to put a little tag on trash and follow it and see where it goes, what goes to the right place, the wrong place. It's almost like we had to design it. It's like designing a miniature cell phone. That's the paper. If you're interested, it's first deployment we did in Seattle with 500 volunteers, 3,000 pieces of trash. This was quite a few years ago. From banana peels to electronics, we put a little tag on all of them. And after tagging all of them, we started following them. $3,000 objects, a day of deployment. After a few days, you see some of the landfills next to Seattle. But then be surprised how far stuff started to travel, sometimes in crazy, unexpected ways. Look at the trace went to Chicago, changed his mind, and went back to California. And this was the first project. Since then, we've been focusing more on e-waste. We've been able to discover places in the middle of the jungle in different parts of the world where a lot of e-waste is illegally, ends up illegally. These are kind of flows of e-waste from the US to the rest of the planet. And again, some of those traces are legal ones, some of them are not. And we're actually going to expand this for the Olympics in 2026 with actually a big deployment. We design now biodegradable, very cheap tag that can be scaled up in the tens of thousands. And so we're planning to do this for the Olympics in 2026 and look at, again, what happens with some of these flows and how we can manage them better. And so we discovered a number of things, including something we discovered was not expected at all. And it happened when a burglar came to our lab at MIT. And this poor guy stole a lot of things, including tags and computers that tell you where they go. And this is what happened. Oh. All right, I will stop it here and look forward to the conversation.
Thanks, Carlo. That was astonishing. That's a huge amount to digest, but we've got a whole group here, both on Zoom and also live streaming on YouTube. And let me simply say, those who've got questions on YouTube, please type it into the chat, and then we can also get some questions from Zoom. But maybe I can kick it off with a couple of questions. And I'm going to apologize, but I'm focusing on the question of, in a way, AI is in the form of intelligence of all these things. Now, there's the book that's about to come out. I mentioned Blaise Guiriakos. I don't know if you heard him when he came to MIT fairly recently. And one of the big issues, of course, is whether or not we've achieved AGI, artificial general intelligence. Well, he's pretty bullish, and he thinks that we have reached AGI. Now, the way that he describes intelligence is to say that intelligence is multiply realizable. In other words, it can operate on different substrates, not just the brain, but also on a computer. And he uses this analogy. Basically, he makes the analogy, which I spoke about last week, of a plane. You know, a difference between a bird and a plane. A bird flies, but so does a plane. They just fly in different sort of ways, but they both fly. And he applies that same kind of model to AI and the brain. You know, the brain is intelligent. It's a biological system. It's intelligent. AI is a mechanical system that was also intelligent. They're different forms of intelligence in some sense, but they're both intelligence. Now, my question really to you is, when you describe these three different forms of intelligence that were part of the exhibition in the Venice Biennale, are they the same form of intelligence, just realized in different sort of ways, or are they different forms of intelligence? I don't know if you know, but Legg and Hutter did some research where they came up with that. So there are 70 different types of intelligence, but even they were not sure whether it's not the same intelligence. Is it the same intelligence, or is it completely different?
Yeah, and Neil, I think you probably also started answering the question, because really it is about what is your definition of intelligence. So if what the point at the Biennale this year, you know, the point we're making is starting with adaptation, so how to adapt to a changing climate and the changing planet, and then, you know, if you want, if that is, and that is style, you know, adaptation is inherently related to intelligence. Intelligence, how, you know, you're able to recognize pattern and adapt to changing conditions. And so if we take such a general definition of intelligence, then yes, they're all the same type of intelligence, just coming from different angles. From, you know, in here, because of the Biennale, is it is you know, it's a Biennale architecture. It is the architectural Biennale, is how we can as architects look at the built environment and leverage the intelligence coming from nature, the intelligence coming from, again, from artificial in a broader sense, is about network and different types of technology, but also what architecture has done for a long time in the collective. You know, it's the beautiful architecture without architects, celebrated by Rudolsky over 50 years ago, you know, in his work and his books and his exhibition at MoMA, and how that also is something we need to look at as we try to find new ways to adapt to a changing planet. So again, I guess, you know, the general answer is that it depends on the definition of intelligence, but we take a definition that's broader enough, then yes, all of them are tackling the same thing.
Well, maybe they just kind of follow on from that. So I was last week was also looking at the difference between what Fei Li is doing with her World Lab, looking at spatial intelligence. And I think also NVIDIA and many other companies are looking at this question. I think also DeepMind in London, and so on and so on. And they basically, the argument that Fei Li makes is you really can't get to artificial general intelligence unless you understand it spatially. And so the whole thrust is how do you generate, and it's a different. I think what they're trying to do is try and generate enough sort of, I guess you call it 3D intelligence, which is very tricky because you don't just scrape that from the internet. You need to have to basically synthetically generate it, but you can do that, and that's really what the focus is on. And yet Blaise thinks you've got to intelligence just through LLMs. Is your view that you need, I mean, I think I know the answer, but do you need to understand it as a spatial form of intelligence or not?
Yes, and the way I see LLMs, I see them as something rather dumb, but they're super powerful, but rather dumb. And why rather dumb? Because, you know, they're, you know, the French have this definition of idiot savant. Idiot savant is somebody who knows everything about everything. But can basically regurgitate it, but little more than that. I think that they're very powerful because think about what we were doing just 3 years ago. If you wanted to get, you were looking for something on the internet, you know, you would look at the top 3, 5, 30 results and go through them and basically blend them in your brain and try to do a summary yourself. And now you got this system that doesn't do doesn't take 30 results, but 30,000 or 30 million results, and can blend them. And they can be for both a text, and can blend them in the length you want, in 100 words, in something longer. It's no surprise. I was looking the other day at statistics based on Google. And basically all the advertising model of Google is vanishing because people are not going to the links. They're just looking at the AI summary at the top. I think where Google provides that is proving disruptive, and people just look at the AI summary, which is just, again, a different way to navigate all of this collective knowledge we've accumulated as humanity. If you think about it, so it's very powerful, but to me is very still rather dumb. Think about, and let me give you another example. If you need to if a client comes to you and wants to do a house on a waterfall in the forest with a beautiful rock and so on, well, again, you might get inspiration 30 years ago, 50 years ago, we look at the inspiration from architecture books and Frank Lloyd Wright, Falling Water, and many other things. A few years ago, if we actually do a little bit of Google to start, just think about what artists have done in this space. And now you got this system that can do a beautiful blend and create new images, looking at all the probably thousands or tens of thousands of waterfall homes that have been designed by architects all over the world. And you get inspiration to that. But again, it's like just, regurgitating past knowledge. These systems will never be able to create the new Frank Lloyd Wright or, to come up with something similar, but they're amazing in looking at the past and slice it whichever way you want. I'll give you a final example of why I think also they're quite dumb. So when with the Biennale, ended up getting a lot of, I told this to a few journalists, and with the Biennale, ended up having a lot of, interview requests. And so my team trained a system, they call it Carlo GPT, that has all of the answer I've given in the past. And basically it can answer any similar question. And this is I still have a pass at all the answers, but the system does a first pass at how to reply. And then the system, if it is something that I've been talking about before, it's perfect. 90% it's how I would have replied myself. But if the system is asks something that is not part of the repertoire, it totally hallucinates. So it doesn't know how to answer. So it just takes the past. It is a beautiful way to slice to the past. But I don't think it's very close to AGI in its present form. And the reason philosophically is exactly what you were saying, is that AGI is based on a constant feedback loop with the environment. While at the moment, LLMs are simply something that gets a huge amount of data that you can feed, and then based on that, you can slice that. But actually the intelligence we are all talking about, I think when you go to general intelligence, is something that's based on this constant feedback loop, like what happens with humans, that every second we got all of the senses in action, and we respond to them. And so I agree with all the approaches that try to go into spatializing intelligence as the next logical step. So I don't think we're there yet. That's my impression.
Maybe just we've got 3 questions in the chat there, but a quick follow-up. One of the kind of controversial things that Blaise says is basically intelligence is about prediction, which is kind of interesting because all the kind of neuroscientists, Carl Friston, Anil Seth, Andy Clark, and so on, talk about prediction as being the important concept that drives how we think. So potentially then it's all about, generative, AI is generative. To what extent do you use the data you've got to generate designs of a certain kind, or is it simply analysis at the moment?
Now, architecture always starts with a very analytical phase. So certainly, you in that phase, if you can look at more dimensions of the city or more dimension of the environment, that's very helpful. It's no surprise that the great Ildefonso Cerdà, who designed Barcelona, the big expansion of Barcelona in the 19th century, if you read his book on the great theory of urbanization, he dreams at the time of having the data we now have about the city. So he says, in the initial chapter, he says, we should one day planning will have access to this type of data and will become almost like a science. And that's because that's the first part. That's the part where you analyze and so on. That part is very analytical, even if the design process later is more based on has to follow a different path and has this more creative part. The beginning is very analytical, and there the data helps a lot. Now, if I understand correctly, your question is how do we use it also in the follow-up parts? I think what is useful is what we were saying before, which is this kind of when you're then trying to find. So there's the first part, the analytical part, but then you're trying different options. And over there, the way usually the design process works is a bit similar to what genetic algorithms do. And so somehow if you use the machine to parallelize, to throw more things on the table, and you use that as a way to step to other design, or anyway to parallelize ideas, that's another field where I think it helps. But ultimately, the synthesis, I think, will always be for now, it is still, will be the human component in that process.
Yeah, I mean, the architecture is obviously a manifestation, or your architectural work, of a kind of, let's say, using it to generate solutions or potential solutions. We've got a series of questions in the chat. Sonia De Jager, do you want to put your video on and just ask your question directly? Is that okay? Yeah. Sonia is doing a PhD on the philosophy of AI in Amsterdam, not an architect.
In Rotterdam. Rotterdam,
sorry.
Yeah, no, thank you. I just finished actually, so it's officially completed, the project. Thank you so much, Carlo, for the presentation. Wonderful and super interesting stuff. I was wondering, it's a very open question. What kind of political problems your research has run into, and which ones do you foresee in the future? And I mean, take it as openly as you want, what you consider political or not.
Yeah, no, thank you for asking. I think that the political dimension for us is very important. And let me tell you, I believe really in feedback, because that's what happens in nature, right? Nature, if you think about how nature tries many things, and then based on feedback loops, we'll see what works or doesn't work. And for instance, when we did the project I began with 20 years ago, 19 years ago, the Venice Biennale, by looking at cell phone data, where we wanted to show both the potential that real-time data can have in cities, and there's no surprise, as I was saying, that today the same data powers our smartphones every time we open a Google map or another map with real-time data about traffic, congestion, and so on. But also wanted to have a discussion about, surveillance society. And so in that pavilion, we had, the two components. We had, look, this could be interesting for many things in society, but it's also about potentially tracking and many of the things we've seen since then. So also that has developed a lot, not only the good applications in our smartphones, but also some of the bad applications that can be done with this technology. And so what I think, and that's why when we do a project, even if the key metric is to do in academia at MIT is about to do the best publication, most impactful publication you can, but we still spend a lot of time in doing videos, in doing small website for the project, in sharing it broadly, in bringing it to an exhibition, the Venice Biennale 20 years ago, but then over the years at Design Museum, at the Smithsonian, in many other places, because I think, that's a way to have this conversation, to get feedback in different ways from society, because ultimately it should be citizens to decide which type of city they want. And so I think, I believe that what we do I think a lot of you are researchers, and you certainly are, if you said you just finished a PhD. And then I think what we can do is make our research more accessible, and again, have a conversation. I think that's a different approach than what people tried in the 20th century. At the time, often it was the idea, okay, you find the optimal solution just to impose it on people. A lot of work, also in planning, was based on that principle. We know what works best and we need to impose it. I believe in something else, which is what we can do is speculate. It's similar to speculative design. We can try different things and then make them accessible to people and then listen to that feedback. So that's how we try to incorporate the political dimension in our work.
Thank you very much.
Gustavo has a question in the chat. Again, you're in the Zoom conversation, Gustavo. Do you want to go and put your video on and ask it? Gustavo?
Hey, yeah, hello. Sorry about that.
Hi,
Thank you
Gustavo.
for the wonderful lecture, Carlo. I really appreciate it. I'm a fan.
Thank you, Gustavo.
Wanted to ask very quickly, since your projects are going into urban infrastructure, how do the politicians and the consultants and the money behind these cities regard your work in a kind of a short-term application time frame instead of a longer-term visionary wish?
Yeah, no, thanks for asking. So maybe it's good to go back to when I was saying about the impact. What I tell to our researchers all the time at MIT is about impact. It's clearly, as I was saying before, you're in an academic environment, so you want to do the most impactful research paper, so publish in a good journal and so on. But that's not enough. And I think the second point is exactly what you're saying, is about how this could have an impact on cities in different ways, on policy, on projects, and so on. And also the third thing is what I was mentioning before in the previous questions about the feedback loop, how this can also be part of a broader conversation about, what, and that's why, all the time, as I was mentioning, doing, data visualization or videos or maybe writing op-eds and so on is a way to have this broader process. So we usually look at those three different levels: the scientific impact, the impact on the city itself in terms of policy, in terms of projects, and also the impact in a way to start a broader conversation about urban topics with the community. Now, in the second point that you're asking about, I think we've seen over the years different things. Sometimes it's enough to do a project and somebody will turn it into something. I remember a very funny email I got from after the first project about tracking trash that I've shown before. And, I think a couple of years later, I got an email from a guy who said, well, I got inspired by the work in Seattle and now did a company that actually uses this to monitor hazardous waste in the United States. I'm making a lot of money and, it's good. I look better at the flows. And the guy said, can I come and visit you to see what to do next? It was great. I think, sometimes you can do something and people can get inspired and do their own thing that has an impact. Sometimes we're working with mayors. We're working out with mayors in Rio de Janeiro. I didn't show it today, to look at the issue of informality, how, for instance, scanning, better mapping favelas can help us to look at new ways to think about property titles. One of the issues in favelas and informal settlements is that people have no property titles. So sometimes it's really in collaboration with the city. Sometimes it is in collaboration with companies. I didn't show it in detail, but the work on taxis in New York 10 years ago led to Uber launch Uber Pool, now Uber Share, into a collaboration with. So I want to say is that the different ways. Sometimes it might be somebody is inspired to do it separately. Sometimes there might be a collaboration. In the case of Uber, they reach out to us and say they will like the idea of sharing rides. Can we work on it mathematically together? Sometimes it is with the mayor of the city, with the city hall and presenting. Sometimes the most beautiful and rewarding for me are the ones where I'll give you an example. I didn't show it today. A project called Treepedia, looking at AI to classify trees in cities globally. And there we started getting really hundreds and hundreds of emails of people who are saying, hey, I'm looking at my neighborhood through the data you're providing with AI and Google Street View. And I want to, ask my mayor to plant more trees. And so in that case, that the change happens really through citizens who somehow might use the research might leverage the research to enact change.
And one follow-up question real quick is how is the data that you showed before and after COVID, how has that changed in the last year or two since you've done the work? It seems as though that there are major shifts, at least in the States, with politics. People have shifted more internal. But how do those weak bonds influence your thinking in future projects?
Yeah, no, thanks for asking. Actually, we got 2 additional projects ongoing that really the extension to what I presented. So that was COVID, and what we saw was before COVID, during COVID, and then in that paper is the beginning of after COVID in 2022, 2023, where you see that when we go back to campus, then weak ties emerge again. So they're still in the initial paper. Now we're doing actually 2 additional piece of research. One is looking at mobility, high resolution mobility in the United States with over 50 million anonymized samples. And in that mobility, we're looking at what is the new normal. So basically, what is what is the new level of smart working or smart working, which seems quite interesting from a mathematical point of view. It's almost like COVID, before the only place where you could get work done was, for most people, was the office itself. And now, that constraints is being released for not for everybody. Again, there's a big inequality. Some, for some jobs, you still need to go to a certain place to work. But for many others, you can be more flexible. And then, we're looking at what is this kind of new normal post-COVID that changed a lot during COVID. And then now it's been oscillating, but it looks like it's plateauing about, again, working from home, working from office, working everywhere, and so on. So that's the second article we are finalizing now. And then the third one is a little bit a follow-up to what I was showing before, which is for academics, we can now look at the papers. Now we are 3 years after the end of lockdown, and we can look at the impact of the papers before COVID, during COVID, and after COVID. So the question is, we know that when we remove weak ties, social networks change. We know they're tied to creativity. So we should be able to see a difference in productivity and impact in the papers in the academic production now that we are a few years after COVID, because then we can look at before, during COVID, and also that we start to see the papers published after the end of lockdown. And so that's something we're doing with somebody who's been doing a lot of work in what is called science of science. So the science of studying how the academic research works, and that's Fortunato at University of Indiana. So we have this piece of research we are doing that's again should be out soon. That's looking at in more detail also what is the impact of before we look at the impact on the network, what is the impact also on productivity and the quality of what we do.
Well, Carlo, thank you very much. I'm so excited to look more into your research, especially how kind of sociological or how it influences a philosophical understanding of contemporary gathering, especially like in crowds or in flow of protests or things like that. It's extremely, extremely interesting. I really appreciate your time this morning.
No, thank you, Gustavo. And I think, what you're saying is something we also want to expand more. And if any of you is interested, very happy to, we love collaborative research, which is clearly one of the issues we are seeing today with polarization is related to these kind of structural networks. I believe that physical space is a beautiful antidote to the polarization we are seeing, because in physical space, you need to confront diversity, while online, you can just, cancel it out, everybody who doesn't think like you. And so basically studying more the consequences of this also on political polarization is something that could help us see how we can address one of today's biggest challenges about the fact that the society is fragmenting in different ways. I believe because we also lack places to bring us together also with all of our diversity. So anyway, what I want to say is that what you are hinting at the end is I think something where we would want to do more work that I think is going to be crucial for better understanding polarization today.
Thank you again. Take care.
Thank you, Gustavo.
Just Gustavo did his PhD at UC Santa Barbara. We also have Mitra, who did a PhD in Cyprus on space syntax. Mitra, would you like to ask your question? She's currently okay. Mitra.
Yes. Hello, everyone. Thank you so much for your inspiring presentation. Yeah, my background, my name is Mitra, and I'm teaching at Heriot University in Dubai. And my background was, as Neil mentioned, it was about related to space syntax, and my PhD was about a new model for analyzing urban form by integrating or using space syntax and historical geographical or Kanzian approach. My question is more related to space syntax and your AI, the vector-based navigation article that you have mentioned. So if AI begins curating the pedestrian routes based not only on distances, but also on preferences like shade or safety or vibrancy. So does the criteria like intelligibility in space syntax, which are the principles in space syntax, still hold, or we are entering a kind of post-syntax era where navigation is personalized and non-configurational anymore? Thank you.
Yeah, thank you, Mitra. First of all, my relationship with space syntax goes down a lot. When I was doing my PhD at Cambridge, I wrote an article at the time on space syntax and actually highlighting some discontinuity that you can call the mathematical discontinuity that you will get on in physical space when actually taking a city and turning the city into lines, according to the space syntax method. But so I got interested in space syntax very early on, and so that was one of the papers and one of the chapters of my PhD initially. And you're right, when we were working on vector-based navigation, that was one of my thoughts was about, well, this is actually somehow corroborates some of the aspects of space syntax. As I said, in my initial article, I highlighted one of the limitations, but also vector-based navigation is consistent with a lot of the hypotheses in the initial Hillier and Hanson book about the social logic of space, about how we navigate space and so on. And going back to your point, well, I don't think that we're entering I think you put it like a post-configurational thing, but I think we can better understand some of those laws related to urban configuration through data. So I think vector-based navigation, as I was saying, is something that corroborates some of the initial thinking in the social logic of space in that book that I think is from the late 80s or I believe or something. So in a similar way, I think that a lot of this work and additional work that will certainly follow up with data becoming higher and higher resolution. Incidentally, when we started with the first project we did at the Venice Biennale, the one I showed about mobility data, the resolution was 10 power 3 in terms of spatial resolution, and in terms of frequency, you had 10 data points per day. Now, 20 years later, you got 3 orders of magnitude in increasing higher resolution spatially and higher resolution temporally. So with more and more this, I think we'll be able to better understand some of those universal laws. So what I want to say is that I think there's still a very interesting domain to understand, like in what you can call the computational social sciences. Some people call computational social science to use data to better understand, patterns and behaviors. So we shouldn't give up on that. We shouldn't just try to think in terms of agent-based kind of simulations. So I think we should still look at that, but with more data, we'll be able to get better model of how our brain works and how we navigate cities and many of the other questions. I think it's the right time today, for instance, to revisit some of the beautiful hypotheses of the 20th century, including Kevin Lynch's one, now with much more data about cities.
Thank you so much. I also have one more question. May I ask it?
Sure.
Yeah. In LEO some systems, as far as I know, it is guiding the autonomous vehicles and pedestrians, right? So the movement writes the map as much as the map writes the movement. So in this way of thinking, do you see that urban planning is shifting from maybe form, from the form before function toward the function before the form?
So it is a beautiful question, and then for everybody listening, is about it's a paper I showed before related to the autonomous boats in Amsterdam, and what that type of intelligence does is much more similar to what we do as humans, because what we do is if we are if we land in a new city, we don't have a map in our brain of the whole city and then navigate, but we build the map while navigating. So it's this kind of feedback. So we start navigating, and while we navigate, we also build our map of the city. And that's what these systems do, which is different than, and it is much more similar to what humans and what nature does, where actually you build the two things together, and then the systems that are based more on the traditional approach, the basically have the map of the whole city, and then whatever system it is, a self-driving car or whatever, will navigate it with all that information. So somehow, to me, what it says is not necessarily the change you're envisaging, but it's something, again, is much more similar to nature, where the map and the navigation, they build each other, they reinforce each other at the same time. And what I would take home is, again, not necessarily a big fundamental change in planning in terms of function, but more about, again, the importance of feedback loops. This is nothing else than a feedback loop where one thing is being built and constantly feed into the other one. It's not about having something fully, the map fully built and precise and so on, and then navigating, but it's constantly having feedback loop between the navigation and the map. And so that's, I think, it goes back to the point I was making before about learning from nature and bringing more feedback loops into design, which, by the way, I think it's a different conversation, but I think is a big problem of modernism, is that we've lost a lot of the feedback loops that we had in traditional architecture and architecture without architects. And that's also why, a lot of the disasters in modernist planning in the 20th century were really because of the failure to incorporate that feedback. So that's what I would take home from a project such as this one, which is more about feedback at all stages, and more than what you're saying, the way you put it, more about function and post-functional urbanism, or how you put it. All right, thanks.
We have a question from Reem. We're really spanning the world today. Reem is in Saudi Arabia. She's originally from Jordan, and she used to work in China for MAD. Reem, would you like to maybe unmute yourself and ask your question? I could also read.
By the way, I want to just tell something to Reem, and also before to Mitra. I understand that Mitra is in Dubai, but we have a small lab in Dubai. So if you'd like to stop by and look at the research going on to both of you, feel free to send me an email and I'll organize it.
Absolutely. Sounds like a great idea. Thank you, Neil, and thank you, Carlo, for this presentation and lecture. I really enjoyed it, and the amount of data is amazing. And I was just wondering, because what you said is put a lot of responsibility to the architect and the data collection and the research, etc. So the first question that pops into my mind is how we could actually, and especially when you mentioned never to think of stealing something from MIT and how we let objects talk to us, it's a different story. So eventually, how can data be safeguarded while still being used responsibly and ethically at all aspects? Because maybe from your perspective, this data will be used as a research for a good thing, but later on, and we've seen it in many ways, unfortunately, it could be misinterpreted. So how could we actually do that as part of our research?
Yeah, no, thanks for asking this. I think the question of data is one of the key questions today. I'm very concerned about the fact that a lot of data is not being shared. So first of all, let me tell you, so I think it's a big issue. Let me first tell you, the way we use it is, in many cases, data that's already been collected. Think about the data from telecommunication systems. When we use it, we want as much as possible to make it open, if possible. Sometimes it's given by companies with an end non-disclosure agreement, but if possible, make it open. But we want to be as transparent as possible and get data that, in most of the cases, I was saying, it's already collected, and then we use it for research, but it's collected maybe to run the telecommunication network or some other network, the taxi network in New York and so on. But we got our own protocols, which are about transparency, which I think is vital. If possible, sharing with everybody else. Once we use it, sharing the data with everybody else. And really, I believe that especially with a lot of AI being today of the form that people call black box. We don't understand how it works. We know it works more or less. We feed it with a lot of data, and then it keeps on doing something, whatever we use in the training set. Then I think that because of that, we should be as transparent as possible in sharing the data we use for training. Unfortunately, so we can do that in academia. Unfortunately, that doesn't happen out there elsewhere. So if you look at, today, there's a lot of data being collected from our phones. Then nobody really knows where it goes and what it's being used for what type of training and so on. So I think that's a big issue, and it's something we should all be engaged and fight for more transparency in the way data is collected and used. Now, GDPR in Europe has been quite good in being a bit more transparency, but still not what we need. I think, especially for all the LLMs, the way they're trained. I think, again, when you go, I believe that for every black box model, the only way to understand how that works is to know what was fed to the model, what the training set was. And I think, that there should be a big battle for democracy we should all have, that everybody, every time we use one of those models, we need to make sure that we know better what type of data was used. So anyway, so the two things, one for society, I'm very concerned, one for academia, somehow the data we're using is quite innocent versus the data that's being collected in our pockets today. And we try to do it according to our code about transparency, being, always in anyway, in academia, in every university, we got ethical review boards. So every time we use this data, we file a protocol, we review it with colleagues. So somehow I'm not too concerned about academia. I'm concerned about what's happening in society today.
Yeah, exactly. Do you think it's possible, similar to what you did with the trash, tracking the trash, that we actually have track for the data, how it moves next to the next to the next?
Look, other people have been thinking about this, including recently also, in order not to have AI pollute, because as we all know, AI hallucinates, and then if you let that into the loop, hallucinations become part of the training set, and so basically you're polluting your thing, and so people have this kind of watermarks in order to see what was generated by AI. In the same way, you can actually use this kind of tracking systems on data itself. People have been discussing this. I think that's an interesting possibility. The question is then, I think that the devil is in the details, how to do it and how to make sure that everybody will follow this, how to design a robust system, but also how to make sure that everybody will follow it. But yes, theoretically, it's a great idea.
Thank you. Thank you so much.
Thank you.
Reem, I should say, is doing the Doctor of Design program in FIU, but she's online, so she's in Saudi Arabia. So we are really spanning the world today. We've actually got a question from MIT, from one of your colleagues, Behnaz Falahi, who is probably in the background. I know you're in Brazil, but she's in the background, probably that image you got there behind you. And Behnaz's question is this. First of all, thank you for your inspiring talk. How do you see this kind of augmented awareness contributing to collective intelligence? Can distributed data meaningfully shape collective behavior and decision-making, or does it need to be embedded in social and cultural practices to create real change? And how might we evaluate it? And she adds, finally, I'm especially intrigued by the Trash Track project.
Yeah. And let me tell you something just more anecdotal about Trash Track. I remember that one of the things we did, I didn't show it today, but we did, was actually allow people to see the last journey of their trash or their waste. And so for every object, they could follow it. And I remember some people came to us at the end of the project and saying, look, really, I changed my behavior. I remember something that was quite simple, but one person came and said, look, I used to drink water in plastic bottles every day, throw them away and simply forget about them. But now I know that those bottles go to a landfill a few miles from home. They will stay there forever. So because of that, they decided to stop drinking water in plastic bottles. And so I think, that's an example. If you go back to your question, right, about collective behavior, if it can happen, if it has to be, you say, embedded in social and cultural practices to create real change, well, I think it can happen in many different ways. And this little example about, the plastic bottle is how this feedback loop happens at the level of the individual. And then, yes, the cultural practices is when you might have more group dynamics taking over. But I think it happens in a whole, it can happen at all these different levels from, again, at the individual level, some examples beyond this one about trash bag. I mentioned before about Treepedia, by actually telling people, giving people a map of trees in their neighborhood and looking at how that compares with other cities or with other parts of the same city. So all of this, somehow it's a way that can start very interesting feedback loops with individuals, the way we see. And at the same time, yes, in other cases, you might have more like group dynamics, or might look at how this might be embedded, as you put it, in social and cultural practices. And about the final thing you say, how might we evaluate? Well, again, data itself becomes a very interesting way to look at change. Remember what I was showing before about looking at AI applied to videos in New York? William White, 1970, end of 70s, beginning of the 80s, the same video today. One thing we're doing now is actually getting webcams to continue monitor this in a way that can give us interesting things both over time and over space, change over time and over space. So somehow I would say that the same data, if you plan it from the beginning, can become a good way to look at how that feedback works and how things change again over time and over space, like in the William White follow-up project. I hope I answered that. I mean, we could talk much longer about this, but I tried to touch upon all the points.
Well, she's your colleague at the Media Lab, so you can maybe catch up with her there. Carl, we've got 3 more questions. Have you got time to answer all of them? And I'll put a limit on that. So maybe I could ask, I would say we're spanning the world today, and Alberto was just finishing his PhD at the UCL, but he's in Chile at the moment.
Yes.
Alberto, to ask you.
Hi. Thank you, Neil. Well, Carlo, thank you for your quite inspiring presentation and all the things you're actually doing. And in my case, I have a quite silly question, maybe. It's about if you think that at a certain point we are going to achieve a truly decentralized AI system or AI way of doing these things, because till the moment we are talking about decentralized data, things like that, but finally we are processing everything in all that or data in data centers, which are controlled by few companies only, and in a way we are suffering a kind of digital colonization in a way. So I'm not sure if you are truly think that at a certain point we are going to achieve a truly decentralized AI.
Yeah, and I don't know, but I wish so. Thanks a lot for asking this, Alberto. I wish so, because I also don't like what I'm seeing now is a model which is very similar to the old mainframe approach, right? You got everything centralized, a few companies taking the lead. And the reason I don't like it is, probably because of the same reason you don't like it as well, is the fact that then you get easily monopolies, you get a few companies with outsized influence on all the planet. It's also become vulnerable points. And we know from the era of mainframe, before the internet, the data architecture is not a really robust architecture. It's also an architecture that can collapse or create big issues, right? And that's why the idea of distributed or distributed architectures such as the internet emerge at the time. So my answer will be, I hope so, and I'm pretty sure that will happen. But I hope so, because I think that what we are building now is doesn't get in this idea of a very resilient, transparent, non-monopolistic structure. It goes in the opposite direction. And so I hope that this will change. Also, I think that what you're hinting at could also be much more sustainable from an energy point of view. I was looking at some colleagues at MIT who Daniela Russa, she's the head of CCEL, and she's one of the co-founders of Liquid AI, is one of the companies developing AI systems today. Their approach is really using liquid networks. She showed me what they're running on smartphone, just with smartphone intelligence, which is totally super impressive. So what I want to say is the distributed system, we might also be able to address what is today a totally unsustainable condition, which is all the energy that these kind of centralized systems are consuming.
Yeah. Oh, thank you very much. Because in a way you are actually mentioning things that we're actually running at a certain point at UCL, the Bartlett, in which I'm actually teaching, and we are trying to train a tiny AI model using cell phones, and it's actually working. It's kind of painful at a certain point, but we are not working with connected with the with the cloud, just completely detached and using our own cell phones like this one, processing data, and it's amazing, but it's painful. But maybe we can work on that direction. Let's say.
Yeah, I hope so. So anyway, mine is a wish, but I'm pretty sure that the evolution will go in that direction.
Oh, yeah. Thank you very much.
My apologies for not saying you were a lecturer at the Bartlett, Alberto. We have a question now from Vasco, who is in Bangladesh. So we're really spanning the world today. Vasco, would you like to ask your question?
Yeah. Thank you, Neil. Thank you, Carlo. Nice presentation. I have a question or a kind of dilemma. Natural intelligence evolves slowly, artificial intelligence operates rapidly, and collective intelligence works rhythmically through communities. How might architecture synchronize these different temporalities?
Yeah, it is a beautiful thing. I think you're absolutely right. I think you could say, I think, if you look at today, natural intelligence, think about the brain, how much it can do, and with so little power. So somehow natural systems are very, 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 really still very impressive. I think, much more intelligent in quote than all of the things we are doing ourselves and calling intelligent. But you're right. I think nature, first of all, there's two parts of I think the time component is in two ways there. One is actually the fact that this took millions of years to develop, and so evolves very slowly. So both the architecture, the brain, has evolves very slowly. But the other thing that is that has a time component is that if you want the tragedy of organic intelligence, of our intelligence, that every generation has to make the same mistakes in order to learn. And so, every 18-year-old needs to have to crash a little bit the car into a wall or to have a small accident in order to learn about it. And the amazing thing about electromechanical intelligence is that if one self-driving car out of 1 billion or 1 million self-driving cars makes a mistake, everybody learns in the same way. So that's you're absolutely right, and those are, and especially the second one is the big limitations about the training set. The training set is something that you need to conquer sometimes in the physical space. Like again, when learning to drive, everybody, yes, maybe you don't crash the full car, but you need to make a few mistakes in order to learn how to drive when you are 18, 16 in the US, 18 in Europe. And while with electromechanical intelligence, if somebody makes one mistake, everybody learns exactly in the same way. So you're absolutely right. I think here it's we are not touching too much on this dimension at the Biennale. The point in the Biennale is more about how we can leverage all different types of intelligence. But you're right that you could actually classify them and use them according to the different timescales they operate at. So thanks for that.
Thank you.
We've got one final question. There are probably more coming in, but I think we should call a halt. This is from Selçuk Ozgo. I hope I pronounced your name right. Who is in, I think, Istanbul. And the question, you can see it in the chat, is how. Well, the first sentence I need to rephrase: how AI will proceed to responsive IoT integrated built environment. I think what he or she means is how will AI become integrated into a responsive IoT sensible. Yeah, and then it goes on to say, do you think activity-based offices can evolve to that kind of systems as first long-term example of cybernetic architecture?
Yeah, I think the next phase, going back to the question we were discussing before about general AI, I think it's vital to get feedback with the environment, and then what is the next logical step is this kind of embedded AI. So where AI is embedded in everything, in robotics, in humanoids, in quadrupeds, in many things, and then it can learn and have this kind of closed loop where it keeps on learning from the environment. So about I see that as a kind of big next step in robotics and in AI, combining and blending the two. So that's for the first part of the question. Now the second one goes back to offices, if I understand it correctly, is about well, you say the first long-term example of cybernetic architecture. I not when I'm thinking about cybernetics, I'm thinking about the very origin of cybernetics and Wiener, and then all of Gordon Pask popularize it for architects and so on. So I'm not sure what you mean. I don't know if you want to expand a little bit of how you mean this about the future of offices. But certainly, if you think about cybernetics more as coupling the digital and physical side, yes, I think I'm just looking at your question in the chat. I don't know if you'd like to elaborate a bit more on that. But I don't know if Selçuk is connected.
That came through YouTube, so it might.
Oh, you think we use it through YouTube? Okay, sorry. So no, you're not connected. But certainly for the first part, I replied to the first part. For the second part about offices being, you say, the first long-term example of cybernetic architecture. I'm not exactly sure from which dimension you're looking at this, but potentially, I would say potentially yes. Probably would require this question a little bit more context to discuss it in detail.
I was just to kind of comment on that. I think I was just looking at this the last week or so. What was interesting is when John McCarthy and others coined the term artificial intelligence, it was deliberately to break away from cybernetics, because AI was included in the old days in that realm of cybernetics, and they wanted to take it in a different direction, not based on life, but more mechanical systems. And it's kind of interesting that John von Neumann and Alan Turing, who both died far too early, were really interested in the brain itself. And that kind of the neural network approach kind of died out as a result of that and other things happening. But now it's coming back in. And in some senses, cybernetics has been shown to have a certain significance that I think it's been much underrated, I would say.
And the key thing about cybernetics is about feedback loops. And so again, if you think about this year of embedded AI, then that would be almost like going back to the origin, going back to cybernetics. So somehow there is an interesting thing that what took off as something different from that original body of work might actually reconverge, because when you're looking at embedded AI, that's going back very close to cybernetics and all the feedback loops cybernetics is based on.
Yeah, but also the fact that, this is again going back to Blaise, his thesis is that life itself is computational, which is pretty an astonishing and controversial kind of thesis, but that's going to come out in his book with MIT Press. So MIT is the center of everything. We've actually got one final last question, if you can manage it, from Kadeen Ali, who, yes, Kadeen's not on Zoom, but let me read it out for you. First of all, amazing lecture. You've had lots of compliments. Thank you. Some of the tools and concepts mentioned, like sensor networks and responsive urban infrastructure, rely on pretty high-tech environments. Do you see ways these ideas could be adapted for developing countries or communities with fewer resources, where infrastructure and budgets might be limited? Kadeen, I would say, is on the DDES at FIU as well.
Kadeen, well, thank you. And I think this is a great question to finish. Yes, apologies today in the selection of project for today. I probably didn't include many of the projects we're doing in the global south. But for instance, we've been working for a number of years with Cape Town. As I was mentioning, we got a new lab in Rio de Janeiro. That's why I'm here. I'm working from the lab in Rio this week, where we're focusing just on informality. And so the answer I would say is twofold. One is yes, we can use a lot of the technologies shown also in a wide range of conditions. And they can have a lot of interesting applications in the global south. In Rio de Janeiro, as I was mentioning, we are looking at images and LiDAR data in favelas collected with the local community in order to better understand favelas and understand how they can be made healthier. Today in favelas is still where you have, because of the urban fabric, where you have most cases of leprosy and TB in Brazil. So how to make them healthier, safer, and also how to look at property titles. A big issue is that people don't have property titles. So if you're able to describe that complex system, you can start thinking about giving property titles to people. So that's one example. So we can use the technology we have today in many conditions. Also, I believe that even technologies that today might not be usable in the global south or in some conditions, they're still worth exploring, because over time, every new technology at the beginning is very expensive, but then over time, prices go down, and it becomes what at the beginning could be devised. It becomes a way to actually bridge the gap. And to give you one example, when we started with cell phone data, in the first project I've shown in 2006, 19 years ago, at the time, cell phones were still very expensive. In the global south, there were not many cell phones and so on. And then it turns out that actually the same revolution a few years later has the most impact when cell phones become very cheap and so on in the global south, with a number of countries leapfrog in terms of, for instance, that mobile banking is much more advanced in many parts of Africa than in the US or Europe, simply because many countries leapfrog. So the answer is twofold. One is that yes, already today, a lot of the things we were looking at, including stuff that's not completely inexpensive, like data from Google, from apps and so on, that can be collected globally. But then sometimes even technologies that today might be, might not be developed at scale everywhere because of their cost, they're still worth investigating, because like we've seen in many cases, including in the case of research based on cell phone, then over time, the same technology can become very accessible and can actually have even more impact in places where people could leapfrog to the next technological development. So cell phone were a great example over the past 20 years of something at the beginning very expensive, that then helped collect data and leapfrog countries where there was no other infrastructure. So that would be my twofold answer. But thanks everybody for a great Sunday conversation, and Neil, looking forward to continuing this. And again, if any of you is in Boston, I'm in Boston. If you're coming to the Biennale or to Milan or to Venice before the end of November or so, let me know, and I'd be delighted to continue this conversation.
Carlo, thank you so much. It's given your schedule, it's incredible. You're so generous with your time, and fantastic. To be continued. I'm going to be in Milan later, and I think it's really important to be able to just dig beneath the surface, because the real problem about Biennale is you're there to enjoy Venice, to see your mates and whatever, and you don't pay enough attention to the actual exhibits when you're there. So to be able to dig deeper has been so useful. This is this incredible conversation that has yielded lots of questions and lots of research ideas, and hopefully collaborations in the future. So thank you, Carlo. Thank you also to the team behind this, who put this together, to Bavleen, to Mitra, and so on, who put the posters together. Fantastic. And to be continued. I think at some stage it'd be great to do an inside session into the Senseable City Lab. We did one with the Media Lab before, to see exactly what's going on, a kind of fly-on-the-wall documentary of the individual research, because it seems there's some fantastic ideas that are coming out, especially, I think, the trash one. That was fantastic. Wonderful. Wonderful. Okay.
Thank you.
Thank you, everyone.
Thank you, Neil.
One final thing, I want to just kind of remind everyone that next week we have the session with Stephen Wolfram. Now this is going to be 3 hours later than usual, 1 p.m. EST, then Catherine Hales and the rest of them and so on. So please come and join us next week. Thank you for everyone for this week. Thanks everyone.